Okay, let me continue. So this has function. Has function is a function. Yeah, it is usually specified as the composition of two functions. What is the two functions? The first is how we can have hash code. Hash code means we have keys and we want to change to a kind of specific integer value. So we call it, this is the hash code. And let me call it is h1. H1 is a function to change the keys into integers. And I have the integer values, but I need to compress. The compression means if I have the integer values, maybe the integer value does not fit with the number of array that I have. So I need to compress this integer into a range of integer between 0 until n minus 1. So this n will be determined. So if the previous example, we use 10,000 for this n, there might be another kind of examples. Yeah. So the hash code is applied first, and the compression function is applied next to the result. So at the end, we have hx. Okay. What is the hx? Hx is the result of the h1. What is h1? It is the hash code. And then after we do the hash code, we do the next h2, which is the compression function. Okay. So we first do the hash code and then compression function. The goal of the hash function is to disperse. So disperse means, yeah, we want to assign this one into a random key, which, you know, maybe we know or maybe we do not know. Okay. So if you learn this hash function, this is the basic of the Bitcoin, or if you use like the blockchain. Okay. So if you understand the hash function, yeah, you can find what is the proper hash code. So in the Bitcoin or in the blockchain, they have their own specific algorithm to change your ID into a specific integer, which people do not understand. Okay. So when we define the hash code, there are some ways to do this hash code. The first, yeah, we need to understand about the memory address. We reinterpret the memory address of the key object as an integer, and then it is good in general, except for numeric and string keys. We can also use the integer cache. We reinterpret the bits of the keys as integer, and it is suitable for keys of length less than or equal to the number of bits of integer. Or we can do component sum. The component sum means we partition the bits of the key into components of fixed length. If your computer is 16-bit or if your computer is 32-bit, yeah, it depends on the computer. And we sum the component. So ignores the overflow. It is suitable for numeric keys of fixed length greater than or equal to the number of bits of the integer type. So there are many other kind of hash codes. Okay? So I just introduced you 3 of these hash codes. Maybe this one should be like this one. There is another kind of hash code. We call it polynomial accumulation. Okay? Maybe it is more complex than the general one. We can partition the bits of the key into a sequence of components of a fixed length. Fixed length, you can determine whether the fixed length is 8 or the fixed length is 16 or the fixed length is 32. I can say that we can evaluate the polynomial. The polynomial, if you know the polynomial means it is starting with a coefficient. Let's say it is a0, and then there is another coefficient a1 multiplied by the z. Z is a kind of variable, and then we can have another coefficient a2 multiplied by z power of 2, and then we have the coefficient an minus 1 with the z power of n minus 1. So it means we have a fixed value of z and we ignore the overflows. Especially suitable for strings. So this kind of string, so for example, the choice of Z33 gives at most 6 collisions on a set of 50,000 English words. So using this kind of idea, actually, it is one of the idea for encryption. You can use this kind of encryption to deal with the password, or how you can develop such kind of code to transfer between one data from one company to another company with more security. So I will skip the explanation about the polynomial. So I will just show you this kind of idea. So what I want to focus on is about the compression functions, because when we deal with the hash code, it depends on the problems. You can deal with the very easy hash code until the very difficult hash code. And now about the compression functions. What is compression functions? We want to put the integers into our array. We have integers, but how we can place the integers into the array? The easy one is using the mode. If we have the n equals to 10, then we just mode n or mode 10. If we have the place with 10,000, then we just mode 10,000. The size n of the hash table is usually chosen to be a prime. You know prime? Prime. I don't know what is the Korean. So 2, 3, 5, 7, 11, 13, 17. Yeah. What is the Korean? Yeah. Who? So. Oh, okay. So. Okay. I always forgot the Korean word of this prime number. So this is the number that can be divided by 1 and its number. There will be no other numbers that can divide this number. The reason has to do with the number of theory, okay, and I do not want to explain this one. Okay. There is a theory for this one, why we need to use the prime number for this n. We can do with another function, multiply, add, and divide. So the multiply, add, and divide, or MAD, please don't confuse with the other MAD. If you're learning the data science, you will have also MAD. In the data science, the MAD is mean absolute deviation. Okay, but it is not the data science. This is another function in the compression function. We call it multiply, add, and divide. And in this function, we have this ay plus b mod n. So we will multiply and then add and divide. A and b are non-negative integers. Non-negative integers, it means it is positive. Okay. Such that the a mod n not equal to 0. Otherwise, every integer would map to the same value. So if the a mod n equals to 0, 0 plus, if there is a mod n equals to 0, it means the b will be 0, okay? And let's say y is 0. So every number multiply with 0 and with 0, it will produce 0. Okay? So we need to avoid this one. So a should not give a 0 number. If you deal with this hash map, we have something like this number. Okay. The cap is the capacity. Okay. Let's say this is 11. So they determine the place. And then P is a kind of random number. And the random number is having a very big range of values. So this will be a kind of, you can see the scale. So the scale is 1 plus the random range p minus 1. So the p is the random number here. It is just for a range for this MAD. Okay. The multiply, add, and the divide. We can have hash function. Okay. So the hash function that I explained before. And then we can check the length and then get the item. And then we can set the item where we want to put the value. Or we want to delete the item and we can resize. So I will not discuss this code, but I would like to discuss more details. How if, when you do with this kind of mapping, there might be a collision. Collision. Do you know collision? Yeah, if it no crash, okay, or the accident. Yeah, we call it, this is collision. The collision occur when different elements are mapped to the same cell. What happened to this one? The example that I explained before, like this one, We call it, this is a collision. Why? Because in one array index, there are 3 elements. Here, in one array index, there are 2 elements. So it means there are collision. So we always learn in the list, okay, or in the array, one index, there will be only 1 element. But now in one index, there are 3 elements. This is what we call as the collision. The problem is when the collision happens frequently, then like this one, the numbers in one index will be more than the other index. Yeah, this index empty. But in this index, there are more values. So it is not balanced. That's why people try to make the algorithms collision handling. How can we handle the collision? So we will learn about this one. The first collision, or maybe if you learn about this one, yeah, this is an example. It's a very good example to see the value. Oh, okay, good explanation. Yeah. So in this example, we have 54. Okay, just for example, 54. And then how many space do we have? 13. Okay, we have n equals to 13 because we have the index from 0 until 12. Okay, n minus 1. Now, if I want to put 54, where should I put this 54? So the easy compression function is k mod 13 because n equals to 13. So 54 mod 13. 54 mod 13 equals to 2. So we put into the index 2 for 54. Let's say 28. 28 mod 13. It is also 2. So we put the 28 into the index 2. That's why we have collision. Okay. Now we will learn about one way to handle the collision. The first is separate chaining. Let itself in the table point to a linked list of entries that map there. So it will check the linked list. The linked list means, yeah, you will check what is the next, what is the next, what is the next. Okay. You remember the linked list. We have 2 kinds of linked lists, singly linked list and doubly linked list. In the singly linked list, we have a connection with every of the place. Yeah. Separate chaining is simple, but it requires additional memory outside the table. Okay. Let's see this one. This is the algorithm for the separate chaining. If I want to get the value, I want to get the value HK. So HK means the hash function from the key K, and then I want to get the K. So AK means I save the object into the index HK. HK is the hash function. HK is the hash function. So I put one object. We know that an object is always K comma V. So I have the key, and then I change the key with the hash function, and then I have integer, and the integer value will be the index in the array. So that's why I have the ahk dot get k. If I want to map, or if I want to put the value, how I can put the value is, first I will put the into a t, okay. So I want to put the k comma v, which is an object, and I want to use the hk, which is the hash function, and I want to use it as a t, which is a place to put this object. If the object is null, then yeah, I can just plus with 1. So it means if I have an array, and if this array is empty, yeah, I can just plus 1. So it is the separate chaining. What about if it is not null? Then if it is not null, yeah, we need to check another possible or the empty space. Okay? So we will check later with example. How about if we want to remove? Yeah, if we want to remove, we just remove this one with the remove function. And then if t is not null, it means if there is an element in this t, then we will minus with 1. Okay, this is the code if you want to use the chain hash map or the separate chaining. Okay. So we will check the bucket, and then if the bucket is known, then it will be an error. So I could not find the item in the bucket. If I want to set item in the bucket, then I will check if it is known, then it is unsorted table, and then I will check the old size, and then for every of this value, yeah, I will put it into one kind of place, j comma k. And then if the table j is greater than the old size, then it will be added by 1. If we want to remove, yeah, just remove like what we learned from the previous one. We can check the table j, and then if it is none, then it will be error. But if it is not, then we just delete. And if we do the iteration, you can see here, for every bucket, after we check the bucket is not known, then we will check each of the keys. So let's see this example with the linear probing. In the linear probing, we want to open address with the colliding item is placed in the different cells of the table. It means we will handle the collision by placing the colliding item in the next available table cell. Each stable cell is inspected is the probe, and then the colliding items lump together, causing future collision to cause a longer sequence of the probes. Now let's see if I have this S function. I would like to have the X mod 13. Yeah, I have the size from 0 until 12. So N equals to 13. Now I have 18. What is 18? Mod 13. And it equals to 18 mod 13 equals to 5. Okay. What I can say is put 18 in the index 5. Okay. And the next 41. 41 mod 13. For this 41 mod 13 is 2. Then I can put 41. Okay, I put 41 in the index 2. What is 22 mod 13? It is 9. Okay. I can put the index 9, the value is 22. Key is 22. What is 44? 44 mod 13 equals to 5. Okay, I need to put into the 5. But what happened in the 5? You already have a value. So I cannot put 44 in the index 5. Instead of 44 in the index 5, I will put into the index 6. So this is the linear probing we will put on the next. What is 59? 59? 7? Yeah. 7. Yeah. Okay. Then we can put 59 in the index 7. And then we have 32. 32 mod 13. It is 6. Oh, there is an element in the 6. Okay, we can put on the next element, 7. Oh, there is another element on the 7. Then we put it on the element index 8. Okay. And then we go to the next 31. 31 with mod 13. It is 5. Okay. Now it is more complicated. 5, we have the value. 6, we have the value. 7, we have the value. 8, we have the value. 9, we have the value. Then no choice. We will put into the index 10. So here is the value. And then 73. 73 mode 13. What is 73 mode 13? Eight. Then 8 we have value. 9 we have value. 10 we have value. 11 it is empty, so we put in the index 11. Okay, and this is the final result. Okay. The search with linear probing. The search with linear probing, if we have the HashTable A with use the linear probing, you know that when you get a value, you need to search. Where is the key? Let's say I already get this result. Okay. Now I want to get the key 73. How can we get the key 73? So you need to find the hash function first. I will get the key k. So we will start from the cell HK. 73 mode 13, it is 8. But actually 73 is not in the index 8. So I need to find where is 73. So first we need to start with the index 8 and then we probe. So means we go to the next consecutive location until one of the following occurs. So we will go to the next, check, go to the next, go to the next, go to the next, until an item with key k is found, or an empty cell is found, or n cells have been unsuccessfully probed. If you find the key, okay, then you will return the key. But if you go to every of the key and there is an empty cell, it means you cannot find the key. Or if you already finish until n times, but you still cannot find the key. So there are 3 conditions. And yeah, this is the algorithm. And if I want to update, so let's say I already have the 73, and I know that the 73 mode 13, actually it is located in the index 4. But now I put the 73 in the index 11. Then how can I find the 73? This is also the same case with the searching. So to handle insertion and deletion, we introduce a special object available which replaces deleted elements. When we remove, we search for an entry with key k, and if such an entry key k, o is found, then we replace it with the special item available and return the element o. If we cannot find the k, then just return null. Or if you want to update, so if you want to update the k, 0, we can throw an exception if the table is full. So the table might be full. So with the linear probing, if the table is full, you cannot add more items. And then we start at the cell HK. We probe the consecutively until one of the following occurs. A cell I is found that is either empty or stores available. What is available? The available is one place or one cell that has been replaced or that was an item previously deleted. And we can also do until n cells have been unsuccessfully probed. So you go until n times and you cannot find any empty space. So we start a k, 0 in the cell I if we find the I index is empty. Okay, so this is the linear probing code. Okay. I think for now you can try to figure out your code, the code by yourself. Okay. Next one is the double hashing. Okay. The first is separate chaining, and the second is linear probing, and the next is the double hashing. In the double hashing, we have the secondary hash function. We call double. So double, you know, double is 2. Okay. So we have first hash function and we have second hash function. Why? Because when you have the first function, if it is collision, then use the second function. Handle collision by placing an item in the first available cells of the series I plus j dk. Dk is a function, which is the secondary hash function, mod n. J will be from 0 until n minus 1. The secondary hash function cannot have 0 values. So the result of dk cannot be 0. And the table size n must be a prime to allow probing of all the cells. The common choice of compression function for the secondary hash is this one. This is the most common function, which is q minus k mod q. And the q will be less than n, and q is a prime. And the possible values for d2k are 1, 2 until q. Let's see an example. So I have the same values with the previous example. I have the 18, 41, 22, 44, 59, 32, 31, and 73. So it's the same. But now I'm trying to use the double hashing. And how it works, let's see one by one. In this case, we have the n equals to 13. And then we have the hk. The hk is the first hash function. And the dk is the secondary hash function. Okay. Now, let's see the 18. 18 mod 13. So I give this example. HK, it means 18 mod 13, the result is 5. Is there any value in the 5? No. Then I will put 18. 41. Yeah, for every of this one, I will calculate 2. The secondary function is 3. How can I get this 3? Yeah, this one. 7 minus k, which is 18, mod 7. 18 mod 7, it is 4. So 7 minus 4, then the result is 3. Okay, so we put here. 41, yeah, the HK, the first hash function is 2. Is there any place in the 2? No. Then we just put here. Okay. What about 22? 22, the first hash function is 9. Okay, there is no value, so we just put here. Even though you also calculate the decay, but yeah, we don't care with the decay at this moment. 44. Okay, now we have 44. But what about this 44? The HK is 5. We have a value of 5. Then we need to check the decay. What is the decay? Oh, the decay is also 5. It means in the index 5, we cannot put the value. We need to find another index. Then we will props. What does it mean by props? We cannot put in the 5, but we can put in the 10. How can we define this 10? We will use this function. We use this function. We will add j. Okay. So I plus j multiplied by dk. So if let's say I place the j equals to 1. So first j equals to 0. What does it mean by j equals to 0? So it means 5, this is I, okay. 5 plus 0 multiplied by the decay. Decay is 5. So 5 plus 0, so it means 5. We cannot put in the 5 because 5 already have a value. Okay? 5 already have a value. Then we can change j equals to 1. If j equals to 1, then 5 plus j is 1 multiplied by dk, 5. So 5 plus 5, it means 10. So we will go to the index 10. What is index 10? Index 10 is here. So we will place 44 in the index 10. Okay. What about 59? 59, the HK is 7 and DK is 4. What about index 7? Yeah, so here is already filled. This is already filled. 5, 2, 9, okay. And then 10, 7. We don't have, so we put the 59 here. And then 32. There is no element here, so we put in index 6, 31. Okay, in the 31, yeah, we have the HK is 5. Oh, 5 already filled in. Then we will check the decay. in the decay, when j equals to 0, so it means 5 plus 0 multiplied by the decay, which is 4. It is still 5. 5 is still not empty, so we cannot use 5. Then we will go to the next j, which is 1. 1 multiplied by 4. Then the result will be 9. 9, oh, it is not empty. Then we will go to the next again. 5 plus 2 multiplied by 4. So the result will be 13. But is there any 13? No. That's why the function is this one, mod n. So 13 mod n will be 0. 13 mod n will be 0, so we place this into the index 0. And the last one, 73. 73 divided, so the first hash function is 8, and the second hash function is 4. Because 8 has no value, then we put in the index 8. Okay. This is the final result with the double hashing. So the performance of the hashing, okay, I think it's the time. Then let me continue on Monday for this performance. It's not that long for this one, but I need more time to explain. So I will continue on Monday.